I'm Astrid. I'm a developer in ThoughtWorks in London. And I want to talk to you today about Kotlin in the real world. And the idea behind this talk is to not only introduce a new modern programming language, but to also give you a more of a personal sort of idea of what it was like to learn it, what it was like to teach it as well. Was it easy? Was it hard? What were the advantages of Kotlin? What were the disadvantages? And also, why did we use it? And would we use it again? So first, I need to introduce you to the challenge that we were facing. So it was last year, I think in May, when ThoughtWorks and the mentoring charity 1 Million Mentors sort of met and discussed the idea of a cooperation. So 1 Million Mentors is a UK-based charity. It's a mentoring charity. I'm going to explain that in more detail a bit later. So about a year ago, they had an internet platform, but it was a bit flaky. It wasn't scalable. It wasn't very secure. So it was a WordPress website with a PHP backend, and it was a lot of problems with security there as well. As for example, the database was publicly available. If you knew the endpoint, you could just sort of call it. And a couple of other sort of problems with maintenance, for example. Something else that 1 Million Mentors wanted is they wanted improved workflows and processes. And this is where I'm sort of going to explain to you what 1 Million Mentors is actually about. So 1 Million Mentors is a charity which connects mentees. Mentees are students between 14 and 24 years. They go to school, they go to universities in some kind of education. And they aspire to a certain career. They're high achievers, they're really good at their courses, but they are often from not so privileged backgrounds. So they don't have the networks, they don't have the tools to sort of know what they have to do to sort of get into a certain career. And this is where the mentors come in. And the mentors, they can be professionals, they can be academics. They have a certain skill set and they are sort of willing to share this skill set. The mentoring coordinators, or the catchy name would be MCs. They work in schools or universities and they are the mentoring coordinators, so they sort of connect the mentor with the mentees. You can see in the pictures there are 3 mentees and 1 mentors, and the usual ratio is 1 to 3, one mentor to 1 up to 3 mentees, basically. Something that was very challenging about a year ago was this matching of mentors and mentees was still done completely manually and offline in Excel sheets. So it often took up to months to sort of match mentors and mentees regarding skill set, reach, and if the mentor was even allowed to work with under 18-year-olds. So we created a mentoring platform during the last year for 1 Million Mentors. Included profile creation, it included online training for the mentors, and it also included a manual online matching. So now it's a lot easier. You can basically filter for the different criteria that you want and then select the mentors which are available and match them to mentees. So this is what the mentoring coordinators are doing. And in January this year, we did actually go live with the new platform. We went live first in Wales, in Cardiff, and have now successfully matched 100 mentors. If any of you are interested in becoming mentors, it's already possible to sort of sign up in Manchester area and West Midlands, and we'll also go live in London soon. So let's now talk about the actual challenge that we're facing, because as we all know, ThoughtWorks is a delivery company, is not a charity, but a consultancy. But we did this project pro bono for this charity. So we didn't have sort of the quantitative, the amount of team members that we would usually have in a team. So we started out with 4 and then later on with 5 core team members. 2 of us were developers and 2 were sort of business, product delivery type of people. Later on, we got 1 more developer, which was great. What we did have, though, is many volunteers. So we had hack nights every Tuesday and later on every Wednesday as well in the evenings. So people that came in and wanted to help us sort of building this platform. We also had loads of people come in to help us for a couple of days up to a couple of weeks if they were sort of not assigned to a client project, so field workers which were sort of in between projects. This obviously required a lot of on and offboarding. So what we needed is a system and languages which are either already known by the developers or which are easy to pick up. And this is sort of what brings us to the architecture and the system that we were actually building. So we had a UI which was a sort of easy win. We built it in React with Redux Saga, and React is a very common framework, so a lot of field workers did already know it and could contribute easily. Then we have a modular monolith, and at first we thought that we might just write it in Java with SpringBoot, because that again is such a well-known programming language, and a lot of field workers do know it. But then we thought, how do developers work? Developers are curious, and developers want to learn new stuff. They want to be intrigued. And so we decided to use Kotlin instead. We used Kotlin with Spring Boot, a well-known framework. At this point back then, we all hadn't really used Kotlin before. And that then brings me to the question, why did we use Kotlin, or why did we decide to use it? Before I'm going to sort of elaborate on the question, I want to give you a brief introduction to Kotlin. So the project of Kotlin was sort of first unveiled in 2011. Kotlin was built by JetBrains, which are also famous for the IDEA IntelliJ editor. Then in 2016, there was a first release, and in 2017, there was a second release, which sort of also allowed code sharing between a JVM platform and a JavaScript platform. 2018 was then the second release, which also allowed asynchronous programming. Yeah, Kotlin is known, or is sort of the idea behind it is better Java. So they wanted to develop a language which compiles and is equally fast, runs as fast as Java does, but implementing a couple of new ideas and concepts to sort of make it easier for the developers. The source code is now, so it has reached its critical mass. The compiler is now written in Kotlin, so it's, I don't know if you can actually see it, but it's 82% are written in Kotlin now. About 2 years ago, it was like 50% of the source code that was actually written in Kotlin. It's an open source project, so if any of you would like to contribute, this is the link down here. Kotlin as well is very impactful on a global ThoughtWorks scale. So it's part of the technology radar, which is sort of a guide that ThoughtWorks publishes every 4 months, I think. And it's sort of, it's an opinionated guide. It's sort of the technologies that we use, that we implement globally. And as you can see here, Kotlin is climbing. I would still encourage to spell climbing with a C, even if you're very big Kotlin fans. But you can see in these pink circles, these are sort of the different Kotlin frameworks which are being currently used at ThoughtWorks globally. Okay, but now let's go back to my initial question. Why did we pick Kotlin? Not only because it's exciting and new, but also because, and that's something that we actually figured out sort of over the process of developing the application, it is relatively easy to pick up for beginners, but also for Java and C# developers. What's quite fascinating about it is that it stands very much in between being an OOP language and being a functional language, or implementing some functional concepts as well. Initially, it was developed to be an OOP language, but it sort of, in a lot of ways, lends itself quite nicely to write some functional code too. And it is well documented. A lot of this documentation also comes from the Android community. So here are a couple of benefits listed. This is maybe not the most objective view, because I've taken the slide from the official Kotlin language website. But Kotlin is fully interoperable with Java. It is very tool-friendly, has a concise syntax, and it is meant to be safe. So if we look at the first point, interoperable, which I think is probably one of the most impactful features about Kotlin, or maybe not so much impactful, but it sort of lends itself really nicely if you have an existing, for example, a Java code base, and you want to start implementing Kotlin. It makes it very easy to start. And the reason for that is that you can completely mix and match your Java, your legacy Java code with maybe a new Kotlin code without losing any functionality. So I've built this this completely meaningless application here. It's a Hello World application, but it says Hello World in Java and it also says it in Kotlin. Oh yeah, nice, you can see it here. So basically I used Maven for it, so it's really easy to set up. I added my Java dependency, I added my Kotlin dependencies, and then I wrote a Java service, which basically just is a print out Hello World in Java, and the Kotlin is the same in Kotlin. Then I have an application class where I basically call both of these services, and you can see down here it sort of runs, and you can completely mix and match them, which is really nice. Then as well, it is very multi-purpose. And then you might say, good, we built an API with it, so we mainly used it we did use it as a JVM language running on the JVM platform. But it also runs in a browser on Android and as native code. And what's really great about it is that the Kotlin community is really diverse. So the Kotlin community consists of Android developers, of sort of JVM, maybe Java developers, and of web developers. And you can have a really great knowledge share between all of these groups. And you actually learn, I actually learned a bit about Android development as well, just because I read about Kotlin. And that's, I think, something that's really great. Then Kotlin is also tool friendly. And I absolutely loved it when I started, so I hope you'll love it too. You can use a lot of ecosystem. You can use an ecosystem that is sort of very popular already, which is great, I think. So we use Gradle to build our application. You can also use Maven and Ant, so you don't basically have to use something maybe new and exploratory. Frameworks, we use Spring for our application. You could also use WordX or Ktor if you want something more Kotlin specific. But again, it is not necessary, which sort of makes the learning curve not as steep, because you can sort of use a framework that you might already know. For object relational model, we use Hibernate, and testing works perfectly fine with JUnit and Mockito. That's Mockito for Kotlin. So if we look at testing, so another great feature about Kotlin, so this is a valid test name, so you can have spaces in tests, you can have literally any kind of character that you want, which you want in your test name, you just need backticks around it. And this is basically how we use Mockito. The difference here is syntactically that you would use whenever instead of when. People sometimes start singing a Shakira song when they write too many tests, but that's okay. Then as well, editors. It obviously works really well with IntelliJ, as it's the same inventors basically. And what's really great for people who would like to build a Kotlin application, but they just don't want to write any Kotlin code. I don't know why that should happen. But you could also write some Java code and just auto-translate it in IntelliJ to Kotlin. There is support for debugging, all the tooling. You have the source code in IntelliJ as well. And sort of look at the source code for documentation. The same is possible in Eclipse as well. It's fully supported. Visual Studio Code, syntax highlighting, and there are plugins for Vim and Emacs to use Kotlin. So then let's talk about the syntax. It is a very concise syntax. Let's look at some examples. So what you can see here basically, so we have immutable, mutable types. So val would be immutable, var would be mutable, and that is quite interesting because it sort of makes you choose. So it's not like, for example, in Java where you maybe create string city equals and you're not necessarily aware about it. So you don't make this decision consciously on whether something is mutable or not. In Kotlin, you're sort of forced to, because you have to decide, do I want to use var, do I want to use a val? Then also we have type inference, so the first two lines basically the same as I know there are different cities, but the definition is the same, so you don't have to spell out string. It sort of infers the type. And then another quite interesting feature, I think, is that the city here is actually not a field, but it is a property. So it comes with a getter and setter, which you can override if you want to. So this is sort of all still in scope of the property declaration. So here I'm overwriting the setter and I'm just saying if the field is not blank, then the value of the field is the value. Then we have collections, we have lists, maps, and sets. And again, maybe a bit of a subtle difference, or maybe a bit of a subtle hint here, is they are by default immutable. So a list of would be immutable, whereas mutable list of would be the mutable type. So it sort of lends itself, again, subtly to write maybe a bit more functional or a bit more immutable code. Then we have data classes. Data classes sort of come with, they're sort of one-line declarations of a class, but it also comes with a lot of sort of boilerplate code which is reduced. So often they're being used for stateful classes which don't necessarily operate on their own methods, but it doesn't have to be. So they have the sort of the full capability of any other class. What they do have is they come with getters and setters, with hash code and equals already overwritten, with a toString method, and also with a copy method. This obviously leads to a really good readability and also cohesion in terms of that you can have multiple of these classes in one file, which makes it quite easy to read. So again, here a comparison to Java. You do not have to read this code, so I encourage you not to. But basically, this mentor class here is the same as this mentor class here, and this is just to point out how much boilerplate code reduction there actually is, and how much more concise Kotlin is to Java. And here, and that gets, I think, personally just quite impactful for developing our application. It affected our architecture in a way. So we used the ports and adapters architecture. So we had this modular monolith. We have our domains, we have an application and a framework around. And obviously we don't want to have the framework leaking sort of into our domain layer. We want to keep them sort of separately and clean. And I think that Kotlin did help us with that again, maybe not as subtly as sort of leading us to write more functional or more immutable code, but just in a way of it being so much more concise, and sort of also the fact that we can have multiple classes in one file just led to us having a very clean domain, and this is our data model, and having all of our annotations and our ORM annotations in the data model. So we have multiple of these actually one-line classes in our data model. And so we were never tempted to actually write our annotations in our domain, just because you can have multiple of them in one file, and it's just so much more concise. Then functions. So in Kotlin, you can write functions without needing them to be within classes, which is great. So you can just have a file with a couple of functions, helper functions in there. It's just very easy to write and set up. Functions are first-class citizens. There is a function type. Functions can be arguments of other functions, can be returned from functions, and functions can be sort of set to variables. Then we can see here we also have Lambda functions. So basically all three of these are sort of the same function, have the same functionality. This is sort of the long way of writing it, and this would be like the Lambda expression. What we see here we infer sort of the type from the property. Here we would infer the type from the Lambda expression, which would make it even more concise. It's just quite simple to use, I think, and that's the main point here. Then, and that is something that I actually just added to my presentation because a lot of Java developers told me that they absolutely love this fact. We have named and default arguments, which is just, again, just something that makes it really, really easy to use in a way, and just very concise. And something that's maybe more of a point of heated discussions is there is no package privacy in Kotlin. So basically, the idea of keeping packages separately works a bit different in Kotlin to maybe other languages. So it's more of a modular approach. So what Kotlin has instead of package privacies, it has visibility modifiers. So you can sort of label classes as internal, as public, as private, as protected. And that's sort of the idea of how you would use encapsulation in Kotlin. But yeah, it is still a heated discussion, and it has been for the last, I think, 3 years. I have followed the threads, and people are quite sort of divided about package privacy. Okay, let's talk about the last point, safety. So basically, there are no null pointer exceptions in Kotlin. And when I say no null pointer exceptions, then I mean, obviously, yes, there are null pointer exceptions, but only if you explicitly throw them. We're going to talk about null safety. That's sort of the first point, then the null pointer exceptions, and then these exclamation and question marks, and then the Elvis operator, which has its name from Elvis, just in case you didn't know. This is where it comes from. But let's start with null safety first. So basically, we have a compile time null safety. So if I set this city string Manchester, if I set this to null, then it will complain because string sort of needs to be a string and can't be null. A way of doing this, and sorry, there is a bit of Java code in here too, but we'll look at the Kotlin code first, which is down here. The way of sort of creating a nullable type, or actually there are nullable types, which you just define with the question mark sort of behind the type, there would be a nullable type. So this is compile and runtime that can be basically null as well. Some of you might be Java developers and might say, oh, there is an optional in Java that can be used. So this is some Java code here. Optional. So I'm actually writing Java code at the moment on my current project. So I use optional quite a lot. And the difference is that it's a wrapper. So it's not compile time, but it sort of only provides runtime safety. To sort of compare those two, I used IntelliJ to translate my code into Kotlin, and there is also an optional wrapper in Kotlin if people would want to use this, but the nullable types are usually seen as more idiomatic. Then let's talk about null pointer exceptions. Here, basically, I'm throwing a null pointer exception, and this would be the only way in Kotlin if you want a null pointer exception to be thrown that it is thrown. So I have validate and create of account details. I have an account detail which can be a nullable. I know this doesn't make a lot of sense because then it is null and then I throw a null pointer exception. But just to show you, this is how you throw null pointer exceptions, basically. Then the Elvis operator, we have the lovely picture again. So basically here you find the Elvis operator. And what we're doing here is we're saying account details. If the account details do exist, so this is the question mark here, they can be null, then look at the detail. So we're accessing the detail if account details exist. And if account details.detail is not null, then account detail is going to be set to account details.detail. Otherwise, we will print this line, this is so wrong. So basically, Elvis operator is a ternary operator using sort of the nullable type as discriminator. Then we also have ADTs, so acrobatic data types, so we're strong with this word, and pattern matching. This is something that also exists in Scala. And basically we have a seal class in Kotlin, which means it's very similar. The idea is very similar to an enum in the end. So we have a seal class user, and if we want to create a new user, this user has to be either a mentor or mentoring coordinator, can't be anything else, which basically makes it safe on compile time as well. So it can't create anything else apart from a mentor or mentoring coordinator. And the way to sort of then test it, or the way to actually to bring this take this further would be with this when is sort of pattern matching approach. If it is a mentor, then we print the mentor, and if it is a mentoring coordinator, we do something different. And that's sort of the idea behind this. Then the question, would we use Kotlin again? Yes, we would use it again. So basically, the experience that we had with Kotlin was we had so many people come in just for a couple of days, just for a couple of hours in the evenings, actually, and they could immediately contribute. I mean, I must say they could immediately contribute if they had any other prior experience, maybe with Java, C# or Scala. It was very easy to learn in the way that people didn't have to sort of go and read some external resources. We could just sort of pair with them and they would pick it up very quickly within a couple of hours. We got a lot of knowledge sharings from sort of the different platforms, and I think, yeah, we just got a really good vibe going with using this language. Then I also have a couple of links for you in case you got interested and you would like to start using some Kotlin. So the first one is actually just the official Kotlin language documentation. The second one is a playground, so it's like sort of like a repo, so you can just use Kotlin online and it compiles. And the third one is Kotlin koans. I have actually never used it, but a lot of people have told me that it's really good to sort of start learning Kotlin. But then again, I think if you have any language background on another JVM language, for example, you will find Kotlin rather easy. I think something else to say as well is for beginners, it is relatively easy to learn it as well because people can focus very much on OOP principles and don't have to sort of think about syntax too much. Because I think as we looked at these examples before, Java has in a way such a convoluted syntax that often as a beginner you're very much focused on getting the syntax right more than maybe looking at the different principles. So in terms of using it as a beginner, I think that's pretty good as well. Okay, and this was it from me, from my side. So thank you very much and stay curious and write some Kotlin.